we conclude our study on geometry with a discussion of circles. So far, we've looked at lines and various types of polygons. That is, geometric shapes with fixed edges. Circles don't really fit into this regime. So circles are not polygons. Depending on how you think of it, circles may be understood as having one edge or infinitely many edges. I'll put this infinity in quotation marks since we really need calculus to be able to make that notion precise. So how is a circle defined? Well, it's typically said to be the set of points at a fixed distance from a center point. So the center point is typically called, well, a center. But this distance that all the points are from the center, it gets a special name. It's called a radius. So we can look at it visually. I pick some center. And then the circle is all the points at some fixed distance from this center. So maybe something like this. And the distance from the center is what's called the radius. The important geometric properties of a circle, like the distance around it and the area it contains, can be understood in terms of the radius. So famously, the area of a circle is A equals pi times r squared, where r is equal to the radius. And pi is the famous 3.141 and so on. Okay, so of course this is infinite decimal expansion, non-repeating, so on. So to compute the area of a circle, I just really need to know its radius. I square that and multiply by pi, that's the area. When we had parallelograms and trapezoids and whatnot, we could talk about its perimeter. All we had to do was add up the side lengths. Here it's not obvious because there's really only one side, or infinitely many, depending on how you think of it. So we say that the length, in quotes, of the circle is called its circumference, not its perimeter. And it can be computed as C equals 2 pi times r. So the area, we squared r. In the circumference, we do not. But we multiply by 2 pi, whereas for the area, we multiply by pi. I'll make a remark that sometimes one discusses the radius of a circle. Other times, what is discussed is something called the diameter, which is the distance of a line going across the circle through the center. So the picture for the diameter might be something like this. This length is the diameter. So notice that the diameter is twice the radius. So it's good to be able to convert between diameters and radius by multiplying or dividing by 2 respectively. With this formula, we can also say that the circumference is equal to, by writing this as pi times 2r, we can say that this is just equal to pi times the diameter d. Both are useful depending on whether you have diameter or you have radius. So let's look at a few examples. We want to find the area and circumference of the following circles. So suppose the radius here is given to be 3. Then I know that the area of this circle is pi r squared, so pi times 3 squared, which is 9 pi. Typically, once you have a number, you'd like to put the number in front of the pi, since it looks a little bit aesthetically better than pi times 9, but that's just conventional tastes. Let's look at another example. All circles pretty much look the same, so you have to say what the radius or the diameter is. So here we'll be given the diameter. We'll say that d is equal to 10. Oh, I forgot to do the circumference here. And the circumference is 2 pi r, so in this case, 2 pi times 3, so 6 pi. Here, we know that the area is equal to pi r squared, but I don't have the radius, I have the diameter. How do I recover the radius from the diameter? Well, I use the fact that d is equal to 2r, so 10 is equal to 2r, so r is equal to 5. This is equal to pi times 5 squared, so 25 times pi. And the circumference is even easier. I can use the formula c equals pi times d to say that this is just 10 pi. So not so bad. The last topic I want to discuss for circles is the notion of an arc on a circle, which is the following. One can imagine taking a wedge out of the circle according to some angle theta. One can then discuss what is the length of this circular arc here, and also what is the area of the wedge, or kind of like the slice of pizza, that I removed from the circle according to the angle theta. Thankfully, there's the same rule for both of them. We say that the length of the arc, which is this distance here, divided by the circumference, the total distance, is equal to whatever the angle theta is divided by the total number of angles, 360 degrees. So this angle divided by the total, 360, is the same as the arc length divided by the total. So basically, they're proportional. Same rule for the area of the wedge. The area of the wedge divided by the area of the circle is, again, equal to theta over 360 degrees. Useful tool. So let's look at an example. Let's say I want to find the wedge area here. So I have a circle with radius 5. And let's say I take out a slice of size 90 degrees, or with a 90 degree angle. So here, theta is equal to 90. So I know theta. but I need to know the area of the whole circle to be able to complete my formula. How do I do that? Well, I know the radius. I know that the area is pi r squared, which in this case is equal to 25 pi. So I conclude that area of the wedge divided by 25 pi equals 90 divided by 360, so that the area of wedge is equal to 25 pi over 4. So I had to first find the area using the area formula and then apply this result. Let's look at one more example that's a bit more complicated. So here, we'll cut out a slice according to an angle of 30 degrees, but instead of being nice and giving you the radial length, I'm going to give you the arc length, 10. And I want you to, again, find the wedge area. So how can I do that? I don't even know the radius, so how can I even find the area of the whole circle? Well, I can use this ratio here to find the total circumference from which I can get the total area. So note, 10 divided by the circumference is equal to 30 divided by 360. Because this angle divided by 360 is equal to the arc length of 10, this length here, divided by the circumference, which I currently don't know. So this tells me that, let's see, 10 over c is equal to 1 over 12, and I can cross multiply to get that c is equal to 120. So that tells me the total circumference is 120. Now, how do I get the radius from that? Well, let's look here. The circumference is equal to 2 pi times r. So I know that 120 equals 2 pi r, which tells me that the radius is equal to 60 over pi. So that initial analysis helped me out quite a bit. It told me what the radius is. But I have to go further now. I have to use the radius to find the area of the whole circle so that I can find the area of the wedge. So now we know that area of the whole circle is equal to pi r squared. So pi times 60 divided by pi, quantity squared. So 3,600 divided by pi is the total area. And now I can conclude. Now I can use this formula here. So hence, the area of the wedge divided by 3,600 over pi is equal to 30 over 360, so that the area of the wedge is equal to this. So what do I get here? Let's see. This should be equal to 300 over pi. All right. So all I did to do that was I canceled this with this and was left with a 10 on top and then multiply everything out. So a tricky problem for sure, and it had many different parts. First, I had to find the circumference using this formula, then recover the radius, then I could finish the problem. You should be able to do a question this hard for the CLEP, as they like to make these questions difficult.